Hi there, Esther. You asked a few questions about this, and you mentioned number one about what would like sine of theta be, but it's specifically relating to give a trigonometric ratio for an angle what's in called standard position at the point xy on the terminal side of angle theta. All of that is based on what's considered the unit circle. This is the main hub of all of trigonometry. Unit circle starts here, and this would be 0 degrees, and it goes around counterclockwise. This would be 90, this would be 180, and then 270 again. And quadrant 1, quadrant 2, quadrant 3, quadrant 4. Just as a quick definition, quick reminder, sine of theta, definition, opposite over hypo. Cosine of angle theta is adjacent over hypo. Tangent over theta equals opposite over adjacent. We commonly know that as SOH TOA. Then you have these inverses. And the first one is cosecant of theta equals hypo over opposite. The way I remember that, I think CHO. And then the opposite of cosine is secant theta, and that's going to be hypo over adjacent. So CHO sha, and then the inverse of tangent is cotangent theta, and that's A over O, and that's cow. At least that's how I remember it. So you have SOHCAHTOA and CHO-SHA-COW. CHO-SHA-COW. It reminds me of like some Asian dessert or something like that. Whatever you can use to remember CHO-SHA-COW, be my guest. Come up with your own acronym, but you need to know those basic definitions. So problem number one says give the ratio in standard form. So that's going to be a triangle whose side lengths are along the axis going up, like so, along the axis, and we're dealing with a triangle right here with a radius of 1. So that would be the radius. And if our terminal point is x comma y, x would be that side, length, if you will. And y is going to be this vertical length. And we position theta right here in the middle. So keep in mind that if our theta is in the middle here, y is going to be our opposite of angle theta. X is going to be our adjacent. And our hypo is going to be the radius of the circle. So keep this image in mind over here for this first one. Put here in the margin for us to see and us to use. All right, so sine of theta, sine is so it's opposite over hypo, and with a triangle in standard form, our opposite is y, and our hypo is the radius. So this would equal y over the radius. And then cosecant. Cosecant is the opposite of sine. So it's cha. Excuse me, cho. Cha is the last one. Second to last, second one. So this is going to be cho. So it's hypo over opposite. So the cosecant of that angle is going to be the radius. Get my color straight here. Radius over y. So it's the exact inverse. Cosine is adjacent over hypo. In this case, our adjacent is x, and our hypo is the radius. And then secant is the inverse, so it's sha. Remember, cho, sha, cow. So this is h over a, which is our hypo is the radius, and our adjacent is going to be x in this case. Tangent is opposite over adjacent, and in this case, our opposite is y, our adjacent is x. Cotangent is cow, so that's adjacent over opposite. So you just flip it, x over y. So that's where that comes from. So when it talks about a terminal side, it means, or terminal point, it's the point on the unit circle, and your x coordinate is always going to be your cosine. And let me explain that a little bit here. So when you have a unit circle, by definition, the radius is 1 because it's a unit, 1 unit circle. So if I have a 1 unit circle, the radius of 1, here's theta, here would 1 be, and here is y, the y coordinate and the x coordinate. So think of what sine of theta would be. Sine of theta is opposite over hypo. So it's y over 1. Cosine of theta is adjacent over hypo. In this case, it would be x over 1. So when you're dealing with a unit circle, x, y, x is essentially whatever cosine of theta is, and y is sine of theta. See how that gets replaced? Obviously, this substitution is only when you're dealing with a unit circle, a unit circle. I think you asked about 3, find 2 negative and 2 positive angle measures that are coterminally numerically closest to 0 with a given angle. So you need to have a picture for this. So negative 45 over here, negative 45. Duplicate this page for you. So in a unit circle, just as a point of explanation, when you're, this would be your 0 point, when you're traveling counterclockwise, you are traveling in the positive direction. When you're traveling clockwise, that is the negative direction. So that's just one simple thing you need to keep in mind there. So when it says negative 45, it means I'm starting here at 0 and I go negative 45, which is exactly halfway to this 90. So this angle right here could be named negative 45. Now, it wants two positive and two negative angles that would meet right there. So the first and most simple one so first one, let's do positive. I could just go from here like so. That would end at that angle, and that would be positive. You can see it's basically 360 minus 45. So one of those angles would be 315. And then if you do another one, you can simply just go all the way around once and then just keep going again. Boom. That would still end at the same place. And you see, you just take 315, you add 360. So the angle 675 also ends at the same place. And then a negative angle, you simply go the other way around so that it ends at the same spot. So that's how you do that one. Let's see, which else did you ask? Two negative, two positive. You didn't ask about 4. Degrees. I'm not sure if you asked about this, but I'm going to explain it because it's pretty simple. So right here, we're to change each angle into degrees. And what makes things wonky with angles is based on the concept of a circle being 360 degrees. Therefore, you have these angles that are 45 degrees, and the whole base 60 system actually goes all the way back to the nation of Babylon. And then we have this wonky thing going on that decimals are not base 60, decimals are base 100. So how do you get from degrees and what are called minutes and seconds, just like minutes and seconds in an hour? This means minute. This means second. So if I have a 24 degree, 18 minute, 25 second angle, so that's like little slivers of angles, the basic equation is degrees, minutes, seconds. So to translate, you're going to use this equation. You're going to take whatever the degrees are and you add whatever the minutes are over 60 divided by 60 plus whatever the seconds are. And because there's 60 seconds in a minute and 60 minutes in an hour, that's 60 times 60. So it's 360. So for example, here, my degrees would be 24 plus I do 18 divided by 60 plus 25 divided by 360. And you're going to need a calculator here. So first I'm going to do 18 divided by 60. And that's going to be 0. Let me keep my color straight here, 0.3. And 25 divided by 360. And that's going to be 0.0694. And then 24. And then you simply add all these up. So 0.0694 plus 0.3 plus 24. And then you get this decimal right here, approximately, because all of this is an approximation whenever you're rounding, at 24.3694. Repeating, I'm not sure where your teacher wants you to round, but this is the equation on how to get from degrees, minutes, seconds into a decimal. Okay. I think you mentioned 6. If not, I'm going to go over it anyways. This looks a little wonky. All right. So you have to kind of think things through slowly. Okay. So let's do sine of 90. What does that look like in a unit circle? Sine of 90. Just come here. Erase everything. Okay, when an angle is at 90, right? And keep in mind that radius is 1. So that means right here at 90, you're going to have a 0 and a 1. That's our coordinate. I put this in the margin, 0, 1. Now we've already established that cosine theta of an angle is your x, and sine of a theta of an angle is your y. So when you're looking here at a triangle, all triangles, you have x, which in this case is 0, and y, which is 1. And then if you were to do a squared plus b squared equals c squared, you would get this, the hypotenuse, or also known as the radius, as 1 as well. So you're going to get a little chart here. So it's going to look a little wonky, but once you establish what your triangle looks like, this will get a little bit easier. So we're working, this is from the presupposition of 90. 90 is going to be, that is a radius of 1. This point right here at 90 is 0, 1. So that's kind of what you're operating at. So this is a triangle, an imaginary triangle. You can't really see it because it's essentially been smushed down to a line. So sine in a unit circle, sine of 90 equals opposite over hypo. Our opposite is 1. Our hypo is 1. So our sine of 90 is 1. So when you see sine of 90 in a unit circle, it's going to be 1. Cosine of 90 is adjacent over hypo. Our adjacent here is 0. Our hypo is 1. and 0 over anything is 0. So the cosine of 90 is going to be 0. Tangent of 90 equals opposite over adjacent. Opposite is 1. Adjacent is 0. That's a 0 in the denominator, which means we have infinity. You were to continue and do cosecant of 90, you simply flip the 1 over 1. And the cosecant of 90 is still 1. And you have secant of 90. You flip that, that's going to be 1 over 0, and you're going to get infinity. And cotangent of 90, you flip this, 0 over 1, and you get 0. So these are all the coordinates at 90 degrees. And then if we were to do 180, let's kind of walk through the 180 process. What would the 180 look like? We'll draw that triangle here. So 180, we start with our horizontal is this point here is going to be, if this is a radius of 1, so technically we're going to be at -1, comma 0. -1, comma 0. So our theta here is cosine is -1 and our opposite is 0. And that means your radius is going to be 1 because -1 squared plus 0 squared equals unknown squared. And you can see right now you're going to end up with your hypo equaling 1. So if you were to do sine of 180, that would be opposite over hypo. Our opposite is 0. Hypo's 1. So the sine of 180 is 0. Cosine of 180 is adjacent over hypo. That's going to be -1 over 1. So it's -1. Tangent of 180, opposite over adjacent. Our opposite is 0. Our adjacent is -1, and you get 0. And you do the inverses. Cosecant of 180 equals, flip that because it's cho, and that's 1 over 0, so it's infinity. Secant 180 equals 1 over -1, and you just flip it. That's hypo over adjacent, and that's still -1. And then you have tangent of 180, oh, not tangent, cotangent. Cotangent of 180 equals cow, adjacent over, adjacent over opposite. Our adjacent this time is -1. Our opposite is 0, so that's going to be infinity. Okay, so these are the various coordinates at 90 and then 180, and you can just keep walking around the entire circle. There is a chart. You can easily look this up if you want, but it's important before you just do stuff randomly that you know where it is coming from. Let's see that, where to go. There it is. So the sine of 90, we already figured out, is Right over here, the sine of 90 is 1. And we're just going to grab this whole thing. I'm going to do all the 90s here while we're here. So the sine of 90, these are quadrant angles, is going to be 1. Let's do all the 90s while you're here. Cosine of 90 is 0. The tangent of 90 is infinity. Is that around? Oh, it's tangent of 180. Okay, any other 90s around? Nope. Okay. And we're going to come over here and grab the 180s. So cotangent 180, we just did that. Cotangent of 180 is infinity. Cotangent 180 is infinity. Cosine of 180, we did that one, is -1. Sine of 180 is 0. Let's see, any other 180s around? Tangent of 180 is also 0. And let's do, what is there a bunch of them? There's 360 and 0. Here's a big hint. 360 and 0 is going to be the exact same thing because it's at the same point. So all of these are going to be interchangeable. So I will do that one as well. So we're going to be here at 360 and at the 0 coordinate. So let's erase. These are called quadrangles, quadrant angles. So in this case, for 0 degrees, also 360, which is the same. There you go. So technically that point right there is going to be 1, 0, right? And if you had a triangle here, and it's kind of like an imaginary triangle because it's smushed together. And here is your theta. This side would be +1. This side, because it is 1, 0, this would be 0. And then if you were to do 1 squared plus 0 squared, you would get this is 1 as well. All right, so let's do our chart. So this would be sine of 0 degrees or 360, that's interchangeable, opposite over hypo. Cosine 0 or 360, adjacent over hypo. Tangent 0 or 360, opposite over adjacent. It's nice if you just set everything up before you do this. Cosecant, cho. Cosecant 0 or 360, that is going to be hypo over opposite. Secant sha 0 degrees or 360, hypo over adjacent. And cow, cotangent 0 and 360 equals adjacent over opposite. Okay, now you take this circle and you just start filling out the chart. Our opposite is 0. Our hypo is 1, so 0 over 1 is 0. Our adjacent, that's going to be 1 over 1, 1. Opposite is 0 in this case, over adjacent is 1. That's also 0. Cosecant, hypo is 1, and our opposite is 0, so that's infinity. Our hypo is 1, our adjacent is 1, so that's 1. Cotangent is adjacent, which is 1 over opposite, which is 0, also infinity. So that's going to be both 0 and 360. That. And we'll start filling more of this out. Cosine 0 is 1. Cosecant 360 is infinity. Secant of 0 is 1. Sine of 0 is 0. Cosine of 360 is 1. Sine of 360 is 0. Any more of those? Okay. So you can do the other quadrants, 270. 270 is the only one I didn't do. You can fill that out yourself following the same process. But there's an entire chart that's probably worthy to be memorized. And therefore, this is tied to this down here. Let me show you how. So knowing this, let's color code this. Cosecant 90, that one. Cosecant 90. No, cosecant 90. Cosecant 90. So cosecant is the flip of sine 90. We have sine of 90. Yes, the sine of 90 is 1. So that means the cosecant of 90 is also 1. So 5 cosecant 90, cosecant 90 is 1. So put a 5 there, a 1 there equals 3. Cosine 180 is right there. Cosine 180 is negative 1. And you simply evaluate from there. So 5 times 1 is 5. This is going to be double negative makes a positive plus 3, and this is going to be 8. All right. So here, if we have sine of 90, we have sine of 90, which is 1. We have negative 4 minus 3 cosecant of 0. Do we have that? Cosecant, no, cosine of 0, which is the same as cosine of 360, which is 1. We're squaring that, so it's just 1 squared, which is 1. So I have -4, essentially minus 3. That's going to be -7. So these are called quadrangles. And there is a big chart that you can make and do all 4. And I did all 4. You might want to take a picture of this if you can. Let me stop share. I did through 270. You could learn to do that yourself, and there's some patterns. So let me get, oops, the light, there it is. Okay, you can take a picture of that. So it's good if you do this chart yourself at least one time, so you can know the process. Let's see, what else did you ask about? I think you asked about that one. When we talked about that one. Oh, 7. I think you asked about 7. Let me double check. Three, 7, and 8. 3, 7. There it is. Okay, so how many degrees does a minute clock rotate in 3 hours? So you have to think that 1 hour, by definition, is going to be 360 degrees. So just keep that simple truth in mind. How many degrees does the minute hand clock rotate in 3 hours? So it's essentially 3 times 360, right? 24 hours would be 24 times 360. And in 45 seconds, so 45 seconds, it would stop here at noon, and then it would go like this. The minute hand would go. That's 45 seconds. Ooh, no, that'd be the second hand. So careful here. So in 1 minute, you're going to go 1 degree, right? In 1 minute, you're going to go 1 degree. So 45 seconds, it's asking how many degrees. 45 seconds out of 60 seconds equals and then you reduce, of course, and that's going to be 3/4, and 3/4 is 0.75 degrees for 45 seconds. Number 8, a tire rotates 400 times per minute. That's important that we're establishing something here. So it's going to go around 400 times, 360 degrees per every 1 minute. That's what it's asking. All right. So for every 1 minute, which becomes 60 seconds, we are going to do 400 times 360. But we went 5 seconds, and then therefore we do x. Now you cross multiply. So you're now 400 times 360 times 5 equals 60 times x divided by 60. And then you can just take it down from there. That was 7 and 8. And I think we got it, my dear. Happy to be online again to help out with additional questions.